Evaluate the following using the graph. So in A, we have the limit as x approaches -1 of f of x. So as x is approaching -1 is right here. As x is approaching -1, f of x is approaching 3. So we would say that this equals to 3. So we can also say that y is approaching 3. In B, the limit as x approaches 9 of f of x. Well, 9 is over here. So as x is approaching 9, f of x is approaching what looks like, so this here looks like about 5 is here, so 4.5, 4.6. So it's an approximation. I'm just going to say approximately -4.6. So we can say that y is approaching -4.6. F of -5. X equals -5 right here. And f of -5 has no value. This set is empty because there's an open circle. So this point right here is not actually included. So you would say that this is an empty set. There is no corresponding y value when x equals -5. In D, the limit as x tends to -5 of f of x. Well, we're going back to our x equals -5. So while there is no f of x value for x equals -5, as x approaches -5, either from the left or from the right, f of x is approaching 4. This is 4 right here. So here we would say that the limit as x tends to -5 of f of x equals to 4. So we can say that y is approaching four, but 4 is not included in the range. Okay. F of 2 is right here. So f of 2 equals 2. Okay. So we could say that when x equals to 2, y equals to 2. The limit as x tends to 2 of f of x. Now, as we're approaching 2, either from the left or from the right, the limit of that is actually undefined because we're not approaching the same limit. Okay, so are we approaching +2 or -2? Because these two values are different when we're approaching 2. It means that this limit doesn't exist. So we would say that the limit as x approaches 2 of f of x is an empty set. And why? Because we are not approaching the same value, the same y value. From both sides. So that means that the limit does not exist.